So now that we've looked at the different types of motion, we've kind of distinguished between constant motion and changing motion. So now what we want to do is we want to look at the forces that are involved in that type of motion. So at the end of this lesson, you should be able to state Newton's second law, determine the net force acting on an object, and use that net force to determine the acceleration of an object. So the questions you'll need to answer in your notes is, what is a net force? You will need to be able to state Newton's second law, know when does Newton's second law apply to an object, and know how to determine the net force acting on an object, and determine the direction of an acceleration acting on an object. So Newton's first law is a model that we use to describe objects that are at rest or moving with a constant motion. We're talking about things whose motion are not changing. When Newton's first law applies, we say that the forces acting on an object are balanced. But sometimes we are looking at an object whose motion is changing. When that happens, Newton's first law does not apply. So we needed a new model to talk about objects that are changing their motion. Newton came up with his second law as a model to describe an object whose motion is changing. Newton's second law says that an unbalanced force results in a change in an object's motion. Remember, we defined a changing motion as an acceleration, and this means that the object can be speeding up, slowing down, or changing direction. When we say an unbalanced force, what we mean is that there is a net force acting on an object. Net force is simply the vector sum of all of the forces that are acting on an object. Remember, forces are vectors, so it's not just important to know how big the force is, but also what direction it's acting in. To find the net force acting on an object, you need to know the magnitude and the direction of every force acting on it. We're then going to use vector addition to determine the net force acting in the horizontal or the vertical direction. When forces act in the same direction, we're going to add them all together for a total. When the forces act in the opposite direction, we're going to subtract them from the total. To keep things straight and avoid a lot of confusion later on, we're going to set a convention about which direction is subtracted from the other. Now, typically, direction to the right is considered positive. The same can be said for the up direction. This would mean that anything acting to the left or down would be considered negative. So we're going to subtract the down forces from the up forces. And we are also going to subtract the left moving forces from the right leaning forces. From the tug-of-war activity that we did earlier, we saw that equal magnitude forces acting in the opposite directions would produce a constant motion. If we have 150 newtons moving to the left and 150 newtons pulling to the right, we can see that those forces are working in opposite directions. That would mean that we would subtract those forces from each other to find the net force. Now, 150 minus 150 gives us a net force of 0 newtons. A net force of 0 means that the forces are balanced and the motion is not changing. Now take this example. In this case, we have different forces acting in opposite directions. The little guy on the left is pulling with a force of 50 newtons, while the big guy on the right is pulling with a force of 150 newtons. By convention, we typically start with the forces acting on the right. So to find the net force, we would take the 150 newtons from the right guy and subtract the 50 newtons from the left guy, since they are pulling in opposite directions. This gives us a net force of positive 100 newtons. So what does that positive tell us? Remember that positives and negatives in science indicate the direction of the vector, and that we define the positive direction as right. So this means that we have a net force of 100 newtons acting to the right. So here, Newton's first law does not apply. The forces are unbalanced, so we need to use Newton's second law to describe the motion. Since we have a net force acting to the right, then there must be an acceleration acting to the right. Try this one. Pause for a second and see what you come up with for a net force. The little guys pulled with a force of 50 newtons each, and the medium guy pulls with a force of 100 newtons. Okay, so we are going to start by taking all of the forces pulling in the same direction and add them together. So on the right side, we have two little guys, each pulling with a force of 50 newtons. And on the left side, we have a little guy pulling with a force of 50 newtons and a medium guy pulling with a force of 100 newtons. This gives us a total of 100 newtons acting to the right and 150 newtons acting to the left. Remember, left is subtracted from the right, so 100 newtons minus 150 newtons gives us a net force of negative 50 newtons. Net force means that Newton's second law applies, and there must be an acceleration. The acceleration occurs in the direction of the unbalanced force. So since we have a negative net force, we have an acceleration acting to the left. So what about these? Pause for a second and see what you come up with. So in the first one, we have 26 newtons acting to the right and 12 newtons acting to the left. Remember, right minus left. So we're going to take our 26 minus 12, and that gives us a net force of positive 14 newtons. The forces are unbalanced, so there must be an acceleration. And since the net force is positive, the acceleration must be positive. Now in the second one, we have two forces acting to the right, and we don't have anything acting to the left. Since we have two forces acting to the right, we're going to add those together. So 180 newtons plus 20 newtons gives us a net force of positive 200 newtons. So we have an unbalanced force to the right, which means our acceleration is to the right. Now this last one, we have 4 newtons pulling to the right, and then we have two 4 Newton forces pulling to the left. So a total of 8 newtons pulling to the left. So we're still doing right minus left. So 4 newtons to the right minus 4 plus 4 newtons to the left. So a total of 8 newtons to the left. So 4 minus 8 is going to be negative 4 newtons. This is an unbalanced force to the left, so the acceleration must be to the left. So you need to know what is a net force, be able to state Newton's second law, know when Newton's second law applies, and use it to determine the net force and the acceleration acting on an object.